Welcome back to the Relational Algebra Series. நாங்க வந்து இப்போ 7வது வீடியோவில் இருக்கோம், which is the 7th video. So in this video, we are going to focus on set difference operation, and also we are going to focus on renaming operation. Yeah, they are powerful tools for filtering data in a relational database. So by the end of this video, you'll be equipped to master increasingly complex queries with this. So let's get started. So we have set difference. And in set difference, we know the notation for set differences, the subtract symbol. So how is this useful? Well, in set difference, we can actually this operation does a specific function. It completes a specific function. So that is this presents only the tuples in first relation which are not in second relation. Okay. So this is the basic idea on set difference, the function of set difference. Here you can see, well, if you have a relation 1, I'm going to teach you about the syntax first. So if you have a relation 1 and you apply set difference relation 2, you'll be with uh, a subset of tuples which are only present in relation 1 when compared to relation 2. Okay, let's say normally if we are speaking in set theory, if we are speaking in set theory, we normally say A minus B. Yeah, let's say A is a set which contains A, B, C, D, E, and B is a set that contains who knows, maybe B, D, E, G, F. Here we can see that B, D, and E are also present in the set B. Therefore, we can say A minus B is equals to A comma C. We can do this in the reverse direction also if we wanted. If you do this like B minus A, well, that will result in what? G and F. Why? Here, B will be the first relation and A will be the second relation. So we have to know that set difference is not commutative. Okay, it's not commutative. We should know that. So G comma F. That's it. So similarly, in relational model, if you have multiple tuples, if you have multiple tuples in relation 1, let's say the relation 1 is, who knows, employees, and let's say the relation 2 is contractors. When you proceed with this specific operation, set difference operation, you will be left with the employees who are not contractors. Employees who are not contractors. This is why set difference is very, very useful in the relation model field or database field. That's why set difference is very important. That's why it's also a basic operation in relational algebra. So I'll teach you with an example. Here there is a table that's called current employees, and there are 4 tuples: Alice sales, Bob engineering, Charlie sales, Dave marketing. And we also have former employees who have left the company, and they are Charlie and Dave, 3 and 4. So if I apply, okay, if I apply set difference, okay, set difference current employees minus or set difference former employees, okay, if I do this, yeah, if I do this, I will be left with only 2 tuples. What are those 2 tuples? Well, Charles sales should be cut in current employees relation, and we have Dave marketing that should also be cut in the current employees relation. So the output will be this specific area. எங்களுக்கு இந்த ரெண்டு டப்புளும் எங்களுக்கு வந்து அவுட்புட்டா வரும். Obviously we have the column names, okay, but in relational algebra we can say that we have only two tuples remaining. Okay, two tuples remaining. The cardinality of the resulting relation, we can say the cardinality is 2. Okay, so this is set difference. Set difference is not that much of a hassle. It's really easy to understand and do. But you have to know that set difference also can only be applied on which are relations which are union compatible. Relations which are union compatible. Okay, so I hope you remember what is union compatibility. And if you have any doubts, I will pin the link in the video so that you can go and watch and come. Okay, now we can move to renaming operator in relation. Renaming operator is a simple idea. There is not much to talk about that. It just does what the name suggests. Okay, so renaming operator. The notation is rho, the Greek letter rho. So there are multiple use cases. I will be explaining one by one. Okay. Let's say you have a relation. Yeah, let's say you have a relation employees. And now you have to rename this employees relation into staff. Okay. And if you have to do this, you can simply use renaming operator. How can you use this? Well, you will put a row and then you will mention which name you should transform into staff. From which specific relation name. So you will say employees. This is how you have to use the renaming operator. Okay, in relational algebra. So what's the idea? The syntax is okay. The syntax is a rename operation, new relation name, new relation name, a whole relation. This will result in changing of relation name. This is one example. And let's say if you have to rename, who knows, some columns. Yeah, you have to rename some columns. The basic syntax is, okay, let's say there are three columns in employees, in employee, in employees, yeah, in employees relation. Let's say there are three columns, imp ID, and you have name, and you also have salary, and you have address. Okay. Let's see, due to some company rules or business rules, you have to change the names into something like this: imp ID, name, wages, and for address, they are telling us to rename the column into info. If we have to change all the specific if you have to change all the specific columns, the syntax is very simple. We just learn from the example first. So you will mention what are the column names you are changing. Well, you are changing into imp id, name, wages, info. So you will mention that imp id, name, wages, comma, info, and you will mention the relation name, employees. Okay, so what's the syntax here? The syntax is simply renaming operation. Okay, new column 1 name, comma, new column 2 name, comma, dot dot dot. We can have n number of names, and we should mention the relation name. In which relation you're making the changes. You have to mention that, right? Relation. These are the basic operations that you can do under renaming operator. Okay. We also have some other applications which I'm going to teach you now. So the third use case. Okay. Now we go to the third use case. Third use case. Let's say you have to change the relation name employees to staff. At the same time, you also have to change the column names to new names like ID, name, wages, and finally, let's say there is info. If you have to do this, just focus on the example first. So you will write down the renaming operator and then you will mention new relation name, staff. Okay. And you will use a semicolon, sorry, a colon. Then you will write down all the new column names. Okay. Emp ID in order. You have to maintain the order. Okay. That's very important. Wages, comma info. And this finally you will mention the old relation name, employees. This is also another method to mention or use relational relational algebra operator, renaming operator. Okay, so what's the syntax here? What's the syntax here? Renaming operator, new relation name, new relation name, colon, new column names, new column names, and finally, old relation. Okay, this is how you normally mention or use renaming operator. And we also have another specific renaming operation, which is if you have to change only one column. Yeah, you can always write down all the columns, right? Let's say you have to convert address column into info column in staff table or staff relation. Okay, so now you will just use the simple way renaming operation. You have to change into info, which column? Address column. In which relation? Staff relation. This is another use case. So the syntax will be renaming operation, uh, new column name, new column X name. Obviously, you are selecting one specific column and you're changing the name into something else. So all column X name. And this will be in which relation? You have to mention the relation name. Relation name. We also have another use case for renaming operators. And in when I'm saying as a use case, let's say you are creating a query that includes union or set difference. Okay. Let's say you have to write a query by using these two operations. And in that case, you can directly use the renaming operator so that it doesn't increase the number of code you're writing. Okay. So mathematically speaking, we are just saving space. Okay. So yesterday in the union video, we discussed about how relations should be union compatible to make them to use them for union operation. Yeah. So how is it done? Let's say there are two relations. One is employee relation and another one is staff relation. And this employee relation has columns emp ID, comma, let's say we have name, and let's say we have address. And let's say in staff relation, we have imp ID. Okay, I mean, staff is here, so I'm gonna use something else. Let's say contractors. Better, contractors. Imp ID, name, and instead of address, let's say they have their designation, or maybe yeah, their department, something like that. Let's say if we have two relations like this, how can we apply union or set difference here? Well, we can't apply directly. Why? We have problem. It doesn't fulfill the requirement for union compatibility to apply union operation. So that's why we will use a renaming operator in this case. Okay. So first of all, we will say rename address into info. So address into info in employee relation, and union or set difference, that's our wish. Okay, that's our wish. So mostly we will be using set difference here, obviously. And here we will say converted rename department into info, department into info in contractors relation. Now we can actually apply your set difference operation by using renaming operation also. Okay, so this is the multiple use cases. These are the multiple use cases that you can apply in relational algebra.
Thank you for watching this comprehensive guide on set difference and renaming operators in relational algebra. If you found the video helpful, give it a like and share it with your friends. Don't forget to subscribe to the channel and hit the notification bell so you never miss an update in our relational algebra series. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.